Okay, Assalamualaikum warahmatullahi wabarakatuh. So now we are in week number 9 for PTK. What we are going to learn now is about energy balance. Okay, so let's go to the next slide. Okay, this is the topic learning outcome for this topic, which is the first one is we are going to list and define the components of total energy of a process system, and then know the form of energy transfer between the system and its surrounding. Define the terms closed process system, open system, adiabatic process, isothermal process, flow, shuffles, specific internal energy, specific volume, and specific enthalpy. And last but not least is learn how to convert an energy or power, which is energy per time, expressed in any unit by calculating kinetic energy, gravitational potential energy of any body mass. And also we are going to learn how to use steam table to solve any energy and mass balance related problem. The next slide is regarding energy balance, which is happen to our body. This is closely related to our diet actually. We can use this as a concept to have our own diet, okay, to plan our own diet. Okay, the first one is where it the intake and also the output is the same. Okay, if you look at the value here, okay, 3000 kilocalorie with 3000 kilocalorie, so there will be no change in your uh, body mass, okay, because we know that whatever goes in will goes out, so there will be no change. Okay, the next one is positive energy balance. Okay, positive energy balance, where the energy intake is greater than energy expended. What does it means? Okay, okay, this is related to the second figure, where the first one, this is the amount of calorie that have been taken by someone, which is 4000 kilocalorie, and then the activities that have been done is around 2000 kilocalorie, so it will result in gain in weight, okay, increase in weight. Okay, okay, the last situation is where, and we call it as a negative energy balance, where energy intake is less than energy expended. This will result in weight loss. Okay, for instance, if someone is taking 200 kilocalorie, and then the activities that have been done consume about 3000 kilocalorie, so there will be a decrease in weight because more activities have been done as compared to the energy that have been consumed, or the intake energy. Okay, sorry, the energy that has been consumed is here, where the output, okay, consume, consume, this is intake, okay, energy intake. So if the intake is lower than the consume one, so it will result in the decrease in weight. Okay, this slide explain about the difference between kinetic energy, potential energy, and internal energy. uh, when we talk about kinetic energy, it will related to any motion of movement. Okay, potential energy due to position. Okay, such as gravitational energy. Okay, must have a delta H here. Okay, and then internal energy other than kinetic and potential energy. When the system is closed, energy is transferred in two ways. Okay, namely heat and also work. Okay, so heat, for example, you can go to this link I have insert in goals. Okay, also you can click this link to look at the explanation on the hot air balloon, where you will learn about the concept of hot air balloon, where if this is the air, this is the heat being applied. Okay, because when we talk about heat, it will we need to talk about T difference between the system and its surrounding, where T is moving from higher to lower T. Okay, for example, if this is our hot air balloon, then we provide heat to the hot air balloon. Okay, the pressure will increase inside here, so it will go and push this boundary. Okay, push. Okay, and then we have another force here, okay, from the outside, so it will be balanced between the at the layer, the heat or the force will be balanced between this boundary, so it will give empty space here, empty space inside the hot air balloon, empty space. So outside here we have cold air. Okay, cold air. As we know, cold air is greater than the hot air in terms of the density, weight, and everything. So it will go to the bottom of the hot air balloon and push the air balloon go up. Okay, it will go up. That's why the hot air balloon will float in the air. Okay, sorry, will float in the air. Okay. Okay, and then the next one is work. Okay, normally we often use this formula for work. W equals force time with displacement. But we bear in mind that actually the formula for this is for force time displacement times with cos theta for anything that uh, have angle when the force and displacement act together. Okay, that's why if we have three condition here. Okay, the first one is we have force goes up, displacement goes down, so the theta here will be 0, and then we know that cos theta is cos 0, sorry, is equal to 1. That's why here we will get force times s times with 1. That's why we get f dot s here. But if we are going to measure about gravitational work, okay, here is work with respect to the displacement. Okay, or in other words, the force that is being applied up. Okay, and then the gravitational is being applied down here. So gravitational work will have theta equals 180, because it is totally uh this is the, sorry, because just now we have theta 0 here, and then if it goes down, so the theta will be 180 here, 180. Okay, so theta 180 is equal to, okay, cos 180 is equal to -1, so it is this formula will become force dot s times is -1, so it will become negative f dot s, which is um, different direction, different in direction as compared to the first one. This is the first one, this is the second one. Okay, okay, just now the first two situations are when someone is not moving, just take out something and just stand up. Okay, so now if we have someone who already take up something and move to the direction this way. Okay, where in other words we have theta equals 90. Yeah, go to the direction, to this direction, right? So we have theta equals 90, so cos 90 equals 0. what will happen to the gravitational work force, gravitational work, it will become F dot S times 0. So WG equals 0. So if you want to have a clearer picture, so you need to go to this link. You will learn more on this. Okay, so what is the conclusion? The conclusion is work and heat only refer to energy being transferred. Okay, energy being transferred, not possessed or contained within a system. Okay, if you go to this link will tell you about how the mechanical energy, electrical, thermal, light energy, which is from sun, chemical energy from our body. Okay, when we do work, so our body have chemical energy. So how does it being transferred to another form of energy? Okay, in this case, it shows how the temperature is increased when all of this energy being applied to the system. So you can watch this video to have a proper understanding. So energy has a unit of force times distance, like have been mentioned previously. So the units will be joule or Newton dot meter or dynes dot cm or feet dot pound force. F refer to force. Okay, pound. lb is force. Lb is pound. F is force. Okay. So another energy unit is amount of heat that must be transferred to a specific mass of water to raise the T at constant P of 1 atm. Okay. This is the last slide for this video where it mentioned about the unit of energy, where we have uh, kilogram calorie or kilocalorie. Okay. Also we have calorie, and also we have British thermal unit, or we call it as BTU, British thermal unit, where mass of mass of water is 1 kilo for kilocalorie. For gram calorie is 1 gram. For British thermal unit is 1 pound mass. This M refer to mass. Okay, and LB refers to pound. And the temperature interval, which is 1 degree C each. However, for British thermal unit is 1 degree Fahrenheit.